Hello, this is Dong-Soo from the Applied Superconductivity Lab. Today we will learn about the boundary conditions. In this lecture, we will cover the two sections on boundary conditions: boundary on a single object and boundary between dual or two objects. The first section, boundary on a single object, discusses force constraint, which applies boundary load or body force on the boundary, and displacement constraint, which contains roller and fixed conditions. The roller condition is related to the Newman boundary condition, and the fixed condition is related to the Dirichlet boundary condition. The second section, the boundary between dual objects, discusses contact and bonded conditions. First, the force constraint applies boundary load or pressure to boundaries. There are different boundary loads such as force per unit area, force per unit length, total force, and pressure. They vary in dimensions in units. Next, the displacement constraint limits the change in displacement to boundaries in a specific direction. First, the roller condition constrains displacement in a normal direction to the boundary where the displacement is zero in the normal direction to the boundary. The roller condition also applies to the curved boundaries. Second, the fixed condition constrains displacement in all directions to the boundary. That is, the displacements are all zero in selected boundaries. The example on the right figure shows the magnet fixed to large and heavy structures, which describes that the fixed condition is a strong condition. Finally, we discuss the contact and bonded boundary conditions. Contact conditions have boundaries that are in contact but not bonded. If we apply force on the outermost turn and pull it, only the displacement of the outermost turn is affected by the contact condition. So, the compressive stress can occur. Bonded conditions have boundaries that are bonded. Similarly, if we apply force on the outermost turn and pull it again, each turn is bonded so that every turn is pulled to the direction that force is applied. In this case, both the compressive and tensile stress can occur. In this lecture, we learned the force and displacement constraints and boundary conditions of contact and bonded conditions. We applied boundary conditions in single or between dual objects to perform a structural analysis. First, the boundary condition in a single object consists of a boundary load, which constrains force, and the roller and fixed conditions, which constrain displacement. Second, the contact conditions have boundaries that are in contact but not bonded, so they can fall apart or separate. The bonded conditions have bonded boundaries that are analyzed as one structure. One of the takeaways is that when the outermost turn is pulled with force, in the contact condition, it only affects the outermost turn's displacement because each turn is not bonded. However, the force affects the displacement of whole turns in the bonded condition.